Now vectors part 2, advanced vector operations. So let's start with scalar product, also known as dot product. IB just use scalar product. Scalar just means number, so that means you're getting a number as an answer. There's two formulas here in your formula sheet. This one we never use, so don't even ignore it. It's the only one we care about right there. So we're going to use this equation right here for our example right there. Now notice this only has 2 coordinate points, but this has 3 corresponding parts. Again, don't worry about it. If your thing only has 2 and this has 3, just ignore the third term. When you have 3, which we'll do later, you use it. So that's this kind of idea. So let's do a dot product. All you do is follow the formula, right? You multiply the corresponding parts. So let's say this is V and W. This will be your V1 times W1, so 2 times -1, plus, and then V2 times W2, so multiply these two, 3 times 4, and you get -2 plus 12, which is 10. And that's how easy it is to take the dot product of two things. Okay, let's move on to the next example, just make sure we have this. So now this one has 3 terms, so let's say this is V and W. So we're just going to do the exact same way as follow the formula. So you multiply the corresponding parts, 2 times 4, plus multiply the middle parts, 3 times 5, and then finally the last third terms, -1 times 2, so you get 8 plus 12 plus -2, which gets you 21. And one more real quick, just to make sure we really have it down. Again, if I'm going to do the dot product of these two terms, again, dot product, this means multiply the corresponding parts. So 6 times 2 plus multiply these two, 3 times -4. So I get 12 plus -12, which actually gives me 0. 0 is a very, very important result. So anytime you take the dot product of two vectors and you get 0, that's special. That means that those two vectors are perpendicular. Now let's focus more on that right now. Perpendicular vectors. So just like I just mentioned, if the dot product of two vectors equals 0, that means that those two vectors are perpendicular. So that means that one vector looks like this, and the other vector looks like this, and you get a little right angle between those two vectors. There are lots of ways. So like same thing. So dot product equals 0 equals perpendicular. Also means the right angles. IB might just say that they form a 90-degree angle, or they might say perpendicular. All those are key terms for. Anytime you see any of that stuff, you do this. So let's do an example. So in this example, find P if the two vectors form a right angle. So the key is right there, form a right angle. You see those words, you think A dot B equals 0. So let's say this is my A, let's say this is my B. Now I know if I take the dot product, it should equal 0. So let's do that. Let's take the dot product of these two things. So multiply the first two corresponding parts. -2 times 5 plus the next two. 2 times P plus the final two. And again, since they form a right angle, it equals 0. And now you just add it. Simplify this down a bit. Add like terms. Solve it, subtract 14 from both sides. You get 2p equals -14 divided by 2. And p equals -7. So there you go. On to parallel vectors. So vectors are very straightforward. Parallel vectors are just multiples of each other. That's what that means there. So if you multiply any vector by a constant, then they're parallel. That's it. So like right here, I have the vector -2, 6, and let's find 3 vectors that are parallel. So all you do is get -2, 6, the vector -2, 6, and multiply by any number you want. So let's say multiply by like 4. So you're going to get -8, 24. Now these two are parallel. Let's do another one. So how about let's multiply by a fraction. Let's multiply by -1/2. So you're going to get 1, -1 times 6 is going to be -3. And these two are parallel. Because again, all you did was multiply by a constant. That's how simple it is to find parallel vectors. Let's do one final one because I got to find 3. So we'll take -2, 6, and I'll multiply that by 10. That's easy to multiply by. You get -20 and 60. And again, these two are also parallel because you multiply by a constant. That's the idea. The final advanced vector operation is how to find the angle between two vectors. So if I give you a vector here, and another vector here, let's say vector v and w, you want to know how to find the angle between those two vectors. Well, just like everything else, there's a formula for it. Right, and we know how to do everything in this formula. That first part, you take the dot product of those two, or I should say the scalar product of those two, which we just did up there. And then what we did in the last video, those are just the magnitudes. Again, absolute value, the magnitude of each one. So you multiply the magnitude of each one. And that's kind of it. You just follow the formula. So let's do an example right here. Alright, so right here, find the angle between these two vectors. So let's just make one of them v, the other one w. It doesn't matter which one's which. And let's just find those couple of things. So first I'm going to need the dot product of v and w. Alright, so that's what's multiply across. Multiply the corresponding parts. So 2 times 1 plus 3 times 0 plus 1 times -3. So 2 plus 0 plus -3, or just -1. So that's a dot product, so that's this part. Now we need the magnitude of each one. So the magnitude of v, right, just follow the formula we did earlier, which is you take the square roots of all these squared. So 2 squared plus 3 squared plus 1 squared. And you get square root of 4 plus 9 plus 1, or square root of 14. Let's do the same thing for w. You get 1 squared plus 0 squared plus -3 squared. So remember, when you square negative, it always becomes positive. So 1 plus 0 plus 9, radical 10. Now that we have everything we need, let's plug into our formula right there. So I'm going to have cosine of theta equals -1 over rad 14 times rad 10. Just type this into your calculator. You're going to get cosine theta equals -0.0845 roughly. Remember, the way you get rid of cosine, if you just want the angle, you do cosine inverse of both sides. So again, we're going to use our calculator and do cosine inverse of both sides. Now you can do this in radians. You get some ugly number you won't understand, but it'll be correct. It's better though if you do this in degrees. So make sure you're in degrees, put that in your calculator, and you're going to get about 94.8 degrees. Now, IB loves 3 sig figs, so you generally only want about 3 sig figs as your answer. It's a decimal. That's the idea. So we have one more example to get through, a more complicated version of how to find the angle between two vectors. So right here. Given points A, 3, 5, B, -1, 4, and C, 2, -2, find the measure of angle ABC. So remember guys, when you remember geometry, when you want to find the measure of angle and they give you 3 letters, they just mean the middle one. So find the measure of angle B, basically, is what they're asking. I want to find the measure of angle B. Now the way you do this, it helps me if I write a little diagram out. So let's say this is A, this is B, and that's C. Remember, you want angle B, so that means that you want the angle from B. So that means you're going B to A is a ray, and B to C is a ray. So you're looking for angle B. Now why this is important? Because now you know your vectors. You have vector BA here. You have vector BC here. So before I can find the angle between these two vectors, I actually got to find these two vectors first, right? So before I can use this formula right here, I actually got to find the two vectors. So let's recap what we did last video. Right, if you want to find BA, that's tip minus tail, so you're going to do A minus B, right? So that's what you do. You always do the tip minus the tail. So in this case, that would be 3, 5 minus -1, 4, which gives us double negative, so 4 and 1. That's the vector BA. Right, and then if I want to find vector BC, so that's going to be BC. Again, tip minus tail, so C minus B, which in this case would be 2, -2, minus B, which is -1, 4. Again, 2 negatives make it positive, so 3, -2 minus -4, -6. So So that's BC. Now I have my two vectors. Now I can use the formula cosine theta equals v dot w over magnitude of v, magnitude w. Where one of these is v, one of these is w, doesn't matter. Let's say v and w, doesn't matter. Right, so now we just gotta fill out that formula. So let's do the dot product. So again, you just multiply the corresponding parts. 4 times 3 plus these two, 1 times negative 6. And I get 12 plus negative 6, which is just 6. We gotta find the magnitude of each one, so let's find the magnitude of the first one. Alright, again, it's using the formula. 4 squared plus 1 squared, so I get radical 16 plus 1, which is radical 17. So now let's find the magnitude of the other one. So the magnitude of BC, which is going to be BC, right? So you take the first term squared plus square root of the second term squared. So I'm going to get 9 plus 36, radical 45. Okay, so now we can have everything we need for the formula. So I'm plug it all in. So cosine theta equals the dot product, which we found up here to be 6, over the magnitude of the first term times the magnitude of the second one. I just got to put that into my calculator, and I get about 0.21693, blah blah blah. And again, to get rid of the cosine, you take the inverse of both sides, take the cosine inverse of both sides. And again, you could do it in radians to be correct, but you're not going to understand as well unless you do it in degrees. If you do it in degrees, you get 77.5. So again, 3 sig figs degrees. And that's the angle between those two vectors.